Every year, more than 2.5 billion car tires roll out of factories worldwide, quietly powering the global economy.
But behind every tire is a massive, multi-billion-dollar industry built on engineering, chemistry, automation.
Today, we're going inside one of the world's advanced tire manufacturing plants to see how rubber, steel, heat. This is how car tires are made.
A modern tire looks simple, but it's actually a chemical masterpiece made from more than 200 materials. Workers unload. Natural rubber bales
in seeing. Synthetic rubber pellets.
Carbon black, silica.
Steel cord. Textile fibers.
And chemical additives that strengthen the final product.
But rubber alone is too soft for the road. So the first major step is compounding.
Inside giant industrial mixers, some the size of a small car, rubber and powders churn together under intense pressure and heat.
These Banbury mixers are the heart of the operation, shearing and blending tons of material every hour to create the perfect compound.
The secret to our durability lies in this process. The mixture reaches peak temperature, transforming the raw material cut to. Close-up shots of sheets of rubber rolling out like dark dough.
Continuous quality assurance is paramount here. Technicians stretch and inspect rubber samples, reviewing material properties on any variation can weaken a tire at highway speeds. This stage is crucial. A small flaw here could lead.
Once compounded, the rubber moves to processing lines, rolled, sliced, cooled, and shaped into.
Most drivers think a tire is one single piece, but it's actually built from layers, each one engineered for a different job.
The thick outer layer that grips the road. Extruders heat and push rubber through a steel die to create the exact tread profile.
Sensors scan the shape to ensure perfect precision.
Sidewalls. These flexible layers protect the tire from impacts and weather.
Rubber is extruded into long strips and stamped with branding, size, and safety ratings.
Inner liner. This airtight layer replaces the inner tube in modern tires.
It's rolled into thin sheets and cut into measured segments. Next come the components that give the tire its strength. High-tensile steel wires are woven into belts. Textile fabrics are rubber-coated.
Steel bead bundles are formed to lock the tire onto the wheel.
All these parts now move toward one of the most fascinating stages: tire building.
Precision is paramount. Here, the inner liner is carefully applied to the rotating drum, ensuring a perfect seal for optimal performance.
Utilizing advanced robotics, the green tire begins to take shape. Sensors ensure even distribution and compaction.
The alignment phase is critical. Robotic arms precisely align the steel belts, applying even pressure across the surface. The final layer of the tread is applied with pinpoint accuracy, ensuring perfect adhesion.
That's why the next stage is where the real transformation happens.
A green tire enters a massive curing press, an oven-like machine that operates at over 350 degrees.
The process is called vulcanization. It changes the molecular structure of rubber, bonding all layers into a single, unified piece.
Steam, pressure, and high heat combine in a perfectly timed cycle, usually 10 to 15 minutes.
A curing mold opens, revealing a finished tire for the first time. The difference is dramatic. Soft rubber becomes tough. Loose materials become one. The tire is now ready for testing. Tire failure at 70 miles per hour can be deadly. That's why quality control is one of the most advanced parts of tire manufacturing. Each tire undergoes multiple inspections. Visual inspection.
Trained specialists check for imperfections, bubbles, misalignment, or foreign objects.
A powerful industrial X-ray reveals the internal structure. The tire spins on a machine that measures balance, vibration, and roundness.
The tire spins on a machine that measures balance, vibration, and roundness.
The tire spins on a machine that measures balance, vibration, and roundness.
Random samples are tested on road simulators at extreme speeds, sometimes beyond 150 miles per hour.
Random samples are tested on road simulators at extreme speeds, sometimes beyond 150 miles per hour.
If a tire doesn't meet every standard, it's rejected.
After inspection, tires move to the final stage, packaging and distribution.
Robotic stackers organize tires by model and size.
Positions. Conveyor belts route them toward loading areas.
Each tire is tagged with a barcode, linking it to its batch and quality records, information used by retailers and auto manufacturers.
Forklifts load stacks of tires onto trucks and shipping containers.
From here, they're headed to automotive assembly plants, tire retailers, online distributors, and warehouses across the country. In the US alone, more than 300 million tires move through this system every year.
From the production line to the open road, our logistics network operates with unmatched precision.
From raw rubber to precision-engineered performance, the modern tire is more than a circle of black rubber. It's a
As you can see on the display, our real-time inventory tracking ensures maximum efficiency and accuracy for every shipment.
Every time you drive, you're riding on a piece of engineering designed to carry thousands of pounds, absorb impacts, handle heat, and keep you safe at highway speeds.
Subjected to intense heat and pressure, the green tire is cured. What emerges is a product of unmatched durability and design. Utilizing advanced automation, the tire building machine precisely layers the inner liner, body plies, and here at the rubber processing line, precision is everything. The automated system ensures every component, from the inner...
Now you've seen the full journey.
This is how car tires are made.
The journey begins here, in the raw material intake zone.
Every component, from silica to steel cord, is meticulously prepared.
Now, the raw materials converge, entering the heart of compounding.
Within these colossal mixers, intense heat and pressure fuse the components.
From this cauldron, the raw compound emerges, pliable and ready for its next form.
A machine extrudes long, flat strips of rubber for sidewalls. A stamping mechanism imprints branding and size.
Inner liner is wrapped around the drum, forming the airtight interior. Body plies, made from textile cords, are layered for stability. Beads are pressed into place, creating the foundation that grips the rim.
Robots pull the rubber into shape as the sheet edges turn up around the beads.
Steel belts are added to reinforce strength and improve performance.
Tread layer is applied on top.
A green tire enters a massive curing press, an oven-like machine that operates at over 350 degrees.
The process is called vulcanization.
Steam, pressure, and high heat combine in a perfectly timed cycle, usually 10 to 15 minutes.
The heavy, metallic door of the curing press begins to slowly retract upwards. Hydraulic pistons guide it smoothly.
The curing press cavity is fully open, revealing a perfectly formed, hot tire. It sits within the mold.
A robotic arm with heat-resistant grippers extends into the open press. It carefully grasps the still steaming tire. The robotic arm places the newly cured tire onto a conveyor belt. The tire begins to move slowly along the line.
A tire comes to rest at a visual inspection station. A worker in clean gloves rotates the tire slowly. A cured tire moves along a conveyor belt into a large industrial X-ray scanning machine.
A computer monitor displays a detailed X-ray image of the tire's interior. Layers of steel belts and body plies are clearly visible.
A tire is mounted onto a uniformity testing machine. It begins to spin rapidly at high speeds. Digital readouts on the uniformity testing machine's control panel show precise force variations. Numerical values fluctuate as a tire is securely mounted onto a large road simulator. Huge rollers beneath it begin to spin at extreme velocities.
From high-speed road simulation to meticulous visual inspection, every detail is scrutinized. This state-of-the-art facility allows us to meet global demand, utilizing robotics and advanced data analysis to optimize the supply chain.
From this state-of-the-art facility, we are redefining what's possible, delivering innovation across the globe.
Utilizing advanced uniformity testing and high-speed road simulators, we ensure every tire meets our rigorous standards for safety and performance.
Utilizing our state-of-the-art uniformity testing and high-speed simulators, we examine the internal structure